Welcome to the weirdest science ever. What if I told you that, deep down, reality doesn't behave the way you think it does? That objects can be in two places at once, that particles can act like waves, and that simply looking at something can change what it does. Welcome to the quantum world, a place so strange that even the scientists who discovered it thought they must be wrong. And our story begins with one man, a man who accidentally broke physics. His name was Max Planck, often called the father of quantum mechanics. Or, if you like dramatic titles, the daddy of quantum weirdness. At the end of the 19th century, physics seemed almost finished. Scientists believed they had the universe mostly figured out. Then Planck came along and said something outrageous. He proposed that energy isn't smooth and continuous. Instead, it comes in tiny packets. He called them quanta. Think of it like money. In the everyday world, you can't pay with half a penny if the smallest coin is 1 penny. In the quantum world, energy works the same way. It's not a flowing stream, it's more like digital pixels, not analog paint. Planck didn't even like his own idea, thought it was a mathematical trick. Spoiler alert, it wasn't a trick, it was the foundation of quantum mechanics. Next comes one of the most confusing ideas in all of science: wave-particle duality. In our everyday experience, things are either one thing or another. A wave is a wave. Particle is a particle. Simple. Quantum objects looked at that rule and said, no, electrons, photons, and other tiny particles behave like particles when you measure them. But like waves when you don't, they can spread out, interfere with themselves, pass through multiple paths at once. It's like throwing a tennis ball at a wall, it's putt, and watching it turn into a ripple in a pond halfway through the throw. Physicists were deeply uncomfortable with this, but experiment after experiment confirmed it. Quantum objects don't choose between being waves or particles. They're both, depending on how you look at them. Which brings us to an even stranger idea. Let's talk about superposition. In classical physics, objects have definite states. Light is either on or off. A coin is heads or tails. In quantum physics, yes, a quantum particle can exist in multiple states at the same time, not switching rapidly, not undecided, actually doing all of them simultaneously, until you measure it. A famous thought experiment imagines a cat that is both alive and dead at the same time, not because cats are dramatic, but because quantum rules are. At the quantum level, particles exist as probabilities, not certainties. They don't say, I am here. They say, I might be here, or over there. Good luck. Now here's where things get personal. In quantum mechanics, measurement isn't passive. You don't just observe reality, you disturb it. And this leads us to one of the most famous principles in all of physics. The Heisenberg uncertainty principle says that you cannot perfectly know certain pairs of properties at the same time. For example, position momentum, the more precisely you know where a particle is, the less you know how fast it's moving. And vice versa. This isn't because our tools are bad. It's because nature itself refuses to give you both answers. A good way to think about it? Quantum particles are extremely sensitive about their private data. The moment you try to measure them, they change their behavior. It's like asking someone their exact weight, bank balance, and search history simultaneously. They panic, they move, they lie. Particles do the same thing, but more honestly. So why should you care about any of this? Because quantum mechanics isn't just theory, it's the reason. Computers work, lasers exist, MRI scanners can see inside your body. GPS knows where you are, smartphones exist in your pocket. The modern world is built on quantum rules, even if we don't notice them. Underneath everything solid and familiar is a buzzing world of probabilities, waves, and uncertainty. Reality isn't made of tiny solid balls, it's made of chances. Quantum mechanics teaches us something profound. The universe is not intuitive. It doesn't care about common sense. And it definitely doesn't care about our comfort. But by embracing the weirdness, we've unlocked technologies, insights, and a deeper understanding of reality itself. So the next time someone tells you reality is simple, remember, at the smallest scales, the universe is doing something far stranger than we ever imagined. And that is the quantum world. Thanks for watching. Remember to subscribe, like, and share this video.